Hello everybody, welcome to Guidance Education channel. In this video, we are going to discuss modern periodic table or long form of periodic table. Please watch the video completely without skipping, and if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us right away start the class. Modern periodic table or long form of periodic table. This is also known as Bohr's table. In earlier periods, the atomic mass was considered as a fundamental property of elements, and all the earlier scientists classified elements on the basis of increasing order of atomic weight. But most of them had their own demerits. But in the long form of periodic table, elements are arranged in the increasing order of their atomic number. When more details regarding the atomic structure was discovered, then it was understood that the atomic number decided the physical and chemical properties of elements. So, Mendeleev's periodic law was amended or modified as modern periodic law in relation to atomic number. It was mostly in 1912 who stated that atomic number was a more fundamental property of elements than atomic weight. Earlier, the identity of an atom or an element was considered as the frequency of the X-ray radiation emitted by that element. So, mostly studied the frequency of the X-ray radiation emitted by each of the elements known at that time. In order to find out whether this frequency of X-ray radiation emitted by the element had any relation with the corresponding atomic number, he plotted a graph of root of frequency against atomic number. He obtained a straight line graph. From this, he understood that the frequency of the X-ray emission was proportional to the atomic number. That is, the frequency of the radiation increases with increasing atomic number. So, he stated that atomic number was a more fundamental property than atomic weight. The modern periodic law states that when elements are arranged in the increasing order of their atomic number, their physical and chemical properties repeat at regular intervals. This repetition of properties at regular intervals is what is known as periodicity of properties. So, according to modern periodic law, the physical and chemical properties of elements is the periodic function of atomic number. What is the reason for this periodicity of properties? We will be able to understand the answer for this question when we know the features. Features or characteristics of modern periodic table. There are 18 vertical columns called groups numbered from 1 to 18 and 7 periods numbered 1 to 7. They are horizontal rows. A close examination of the modern periodic table shows that the valence shell of each group has characteristic electron distribution. Valence shell, is the outermost shell. For example, first group elements have outermost valence shell electron distribution as ns1. N is the number of the period which is incidentally equal to number of the principal quantum number. You will understand this better as we proceed with the class. On the basis of the valence orbital to which the last valence electron enters, the groups are further classified into S block, P block, D block and F block. The first group and second group belong to S block and 13th to 18th group belong to P block. S block and P block form the representative elements. In the S block, the last valence electron enters the S subshell, and in the P block, the last valence electron enters the p subshell. Groups 3 to 12 constitute the d block elements and the last electron goes to the d subshell. They are also called transition elements. The F block elements belong to the 6th and 7th period within the D block or transition elements, but their last electron goes to the F subshell. So they are called inner transition elements. The F block elements are shown separately at the bottom of the periodic table. There are two rows of them. The first row constitutes the lanthanoids and the second row consists the actinoids. We will have a look into the periodic table. It is very easy to draw a periodic table if you know the detail. But there is no need to prepare a periodic table at this level for you. I would recommend you not to waste time on trying to draw one. You have to rather spend time on understanding the details, the features of the periodic table. I have already prepared one. All the boxes excepting the last three with a dotted line have elements. I have not shown all the elements here. You can note the 18 groups which are vertical columns. The downward arrow shows the direction of the group. These are the 7 horizontal rows called the periods. In the first period, there are only 2 elements, hydrogen and helium, and the valence shell electron configuration is 1s1 to 2. That is, for hydrogen, it is 1s1 and for helium, it is 1s2. Elements in the first period has only one shell and that itself is the valence shell. In the second period, there are 8 elements from lithium to neon. The second period elements have 2 shells and the second shell is the valence shell. And the valence shell electron configuration is 2s1 to 2 and 2p1 to 6. In the third period also, there are 8 elements from sodium to argon and the outermost shell is the third shell. Electron configuration is 3s1 to 2, 3p1 to 6. The total number of shells for the third period elements is 3. In the fourth period, there are 18 elements. Valence shell is the fourth shell and electron configuration is 4s1 to 2, 3d1 to 10, 4p1 to 6. The fourth period elements have a total number of 4 shells. 3d orbitals start getting filled up in fourth period in the transition group. Similarly, in the fifth period also there are 18 elements and there are a total of 5 shells. The valence shell will be the outermost, that is the fifth shell, and the electron configuration as is shown there. Please make a note. 5 is 0 to 2, 4d 1 to 10, 5p 1 to 6. For the transition element palladium, atomic number 46. The 5s orbital is empty. There are no electrons there in that orbital. 4d orbitals start getting filled up only in fifth period. That is the transition elements. 4f and 5d orbitals get filled up in sixth period. Sixth period elements have 6 shells in all. The outermost shell is the sixth shell and the electron configuration is shown there. The 4f series elements is shown separately at the bottom. Elements from atomic number 58 to 71 are the lanthanoids or 4f series. There are 14 elements in the 4f series. In the sixth period, you will find there is a discontinuity in the atomic number between 57 and 72. So the elements of the sixth period lie in 2 different places and the total number of elements is 18 plus 14, 32. This is the longest period in the periodic table, that is the sixth period, and period number 1 is the shortest with only 2 elements. Seventh period elements have a total number of 7 shells, and the seventh shell is the valence shell. 5 f orbitals and 6 d orbitals get filled up in this period. The 5F series are shown separately at the bottom. There are again 14 elements in the 5F series from 90 to 103. Please note the corresponding discontinuity in atomic number in the 7th period D block. So the total number of elements in the 7th period becomes 14 plus 15, that is 29 only. As 3 final blocks or boxes are not filled, this period is otherwise called incomplete period. The 5F series are called actinoids. So we have seen the period-wise valence shell electron distribution. Now let us see the group-wise valence shell electron distribution. For the first two groups, that is group number 1 and group number 2, the last electron goes to the S subshell. So for group 1, the valence shell electron distribution will be NS1, and for group 2, it will be NS2. So these two groups are called S block. For groups 13 to 18, the last electron will move into the P subshell of the valence shell. Therefore, group 13 to 18, the elements are called P block elements. The group-wise electron distribution for the valence shell will be NP1 to NP6. Groups 3 to 12, the last electron goes to the corresponding D subshell. So they are called D block elements or transition elements. Their D subshell electron configuration will be N-1 D 1 to 10. The F block elements are shown separately at the bottom. That is the sixth period elements between lanthanum and hafnium, and seventh period element between actinium and rutherfordium. The last electron go to the corresponding F subshell. The F subshell electron configuration will be N-2 F 0 to 14. In thorium, atomic number 90, the 5F subshell is empty. F series are otherwise called inner transition elements because they really belong to transition elements. You may note that they are not allotted group numbers. The 4F series and 5F series are given separately in order to make the periodic table more compact. The F block form the inner transition elements. I will make a note of that. I have also noted the S block, P block and D block. So you can note that the elements are arranged as per Aufbau principle of arrangement or filling of electrons. I expect that now you are able to give the answer for a question that I asked in the beginning of the class. That is, what is the reason for periodicity of properties of elements? You have understood now that the electronic configuration is repeating at regular intervals. That is the reason why properties are also repeating at regular intervals. That is periodicity of properties. The left hand side of the periodic table are all metals and the right hand side is non-metal. But the elements on either side of the red zigzag line that is shown, those elements show metallic and non-metallic properties. They are metalloids. So from the left hand side, the metallic property of elements slowly shift, and through metalloids, the elements start showing non-metallic property towards the right side of the periodic table. Before I wind up this video, let me make one more point quite clear. Now, accepting the three boxes in the seventh period where I have shown dotted lines, all the other boxes in the periodic table have elements. I have just shown those elements which I need for the explanation I have given. Moreover, most of the elements in the seventh period are artificial or man-made elements. For most of them, the IUPAC is yet to provide symbols and names. Hope this video was of great use to you. If you think it is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and also press the bell button and all button for notification of more videos like this. Thank you very much. Bye for the present. Take care.